Hello everyone and welcome to this tutorial. Till now we have completed these two important steps: data pre-processing and model building. In model building we have tried three different machine learning models: multiple linear regression, random forest regression and XGBoost regression. And after that, on the basis of R2 score, we have finalized random forest regression. Now in this tutorial we have to do hyperparameter tuning. Let us begin. Open sklearn documentation. Then go to API. And here we have to look for model selection. Scroll down. This one, model selection. And here this one, randomized search CV. Open in new tab. For the parameter tuning, we are going to use this class randomized search CV, and we have to import this class from sklearn.model-selection. So copy this from sklearn.model-selection, import randomized search CV and execute. Let us understand the main difference between grid search CV and randomized search CV. In randomized search CV, not all parameter values are tried out, whereas in grid search CV, all parameters are tried out. So this is the main difference between randomized search and grid search CV. And because of this difference, this one, not all parameter values are tried out in randomized search CV. It takes little time than the grid search CV. And that's why we are using randomized search CV. Now go to Colab notebook. Now we have to tune the parameters. Go to random forest official documentation, this one. First parameter is n estimators. So copy this, define a variable, parameters, this will be a dictionary. First parameter is n estimators. We will try different estimators, 200, then 400, 6, 8, 1000, 1200, then 14, 16, 18 and 2000. So these are the all n estimator values that we are going to try. Let us move forward to the next parameter. After n estimators, we will tune this parameter. Max depth. Copy this. Specify values from 10 to 100, 30, 40, 50, 60, 70, 80, 90, 100 and then none. So this is the maximum depth of the tree. Then scroll down this parameter, minimum samples split. Copy, in single quotes paste. We will try three values only, 2, 5, 10. So this is the minimum number of samples required to split an internal node. The next parameter, minimum samples leaf. Here also we will try three different values, 1, 2 and 4. Let us check for the next parameter. This one, max features. Copy. We will try these two values. First one is the auto and second one is this one, SQRT. So this is the number of features to consider when looking for the best split. Then scroll down. This one, bootstrap. Copy, paste. There are only two values, true and false. Whether bootstrap samples are used when building trees. If false, the whole dataset is used to build each tree. Now we are not going to tune all other parameters. We will tune only these 6 parameters. Execute. Check this variable parameters. Great. Now create an instance random underscore CV, and this is the instance of this class randomized search CV. First we have to specify estimator regressor underscore RF, that is random forest, then parameter distributions, this one parameters, this is the variable that we have defined here. After that, number of iterations, I will specify 50, then CV 5, by default CV is equal to none. Let us check what is CV. Here we can see in official documentation, this is the cross validation generator. By default it is none. Then verbose is equal to 2. After that, n jobs is equal to -1. Let us understand this. N jobs, by default it is none, and when n jobs is equal to -1, that means we are using all the processors. And at the end specify random state is equal to 0 and execute. Great. Now we have to train the model. Random CV dot fit, and in parentheses x train comma y train, and execute. So the model training is started here, this one. It will take a little bit time, around half an hour. Till then you can take tea or coffee, whichever you like, and I'll do the same. So here we have successfully trained our model. Now scroll down, type random CV dot best estimator and execute. So these are the best estimators. Type again random CV dot best parameters. So these are the best parameters. Bootstrap is false. Maximum depth is 50. You can see here there are multiple values of maximum depth from 10 to 100 and none. Out of these 11 values, best value is 50. Then max features SQRT, minimum samples leaf 1, minimum sample split 2, and n estimators 1200. So these are the best parameters. Now add one more section, part 4, final model, and in parentheses random forest regressor. Now copy this model, paste here. Now we will call only regressor, and here we have to specify the best parameters. Copy all these from best estimator, paste here, and train the model. So here we have successfully trained our final model with the help of these best parameters. Now check the accuracy. To do that, redefine ypred regressor.predict method, and at the end calculate R2 score. So the R2 score is 0.8425 and previously it was around 8435. Now it is in similar range. Now go to random forest regressor. So this value keeps changing. It is between 81 to 83. Now it is around 84. And this is because I reran all the cells multiple times. Scroll down. So this is how we can tune the parameters and finalize our model. To tune the parameters, you can try multiple options as well. To tune the parameters, you can try multiple combinations, as well as you can tune other parameters that we haven't used here. So this is all about house price predictions. Let us revise what we have done in this project. First, we have done data pre-processing. Here we have imported the libraries and dataset. After that, we have done data exploration. Then we have dealt with null values. After that, we have drawn dist plot. Then correlation matrix. After that, we have dealt with categorical values. Then we have splitted the dataset into training and test set. And at the end, we have applied feature scaling. In second step, we have built three different regression models. These three: multiple linear regression, random forest and XGBoost. And on the basis of performance, we have finalized random forest. After that, we have tuned the parameters, and this is our final model, random forest regressor. So this is all about this project. I will see you in the next tutorial. Till then, happy learning.